PP days and QQ days are two fixed infinite long straight wire, both parallel to z-axis with a current I in each wire. ABCD is a square loop of side 2L, side AD and BC are parallel to z-axis, and AB in xy plane and CD in plane of xy. PP days and QQ days are cutting x-axis at minus a comma 0 comma 0. This is PP days, which is at x is equals to minus a comma 0 comma 0, and this is a comma 0 comma 0 means separation is 2a, and 2l is less than 2a. Length this 2l is less than 2a obviously, so it can rotate in any direction about z-axis, which is passing through the center. ABCD loop is free to rotate about z-axis only, which is passing through its plane from the center of ABCD loop. Side AB loop is making an angle phi with the x-axis. Choose the correct statement. So here value of phi is changing in options, and we have to calculate for the torque on the loop about z-axis. Torque on ABCD loop z-axis in situation phi is 0. If phi is 0, it means this is the loop, and if this is loop, then this is the current, and magnetic field is inside due to this, and magnetic field due to this one is also inside. And phi is 0, so if we draw the diagram and say that magnetic force on this loop is I and B is inward, so magnetic force will be in this direction. We can say that magnetic force on loop, which is like this is the current I, and magnetic field here is inward. Then the force on this is like this, F, and on this force is like this, and on this we can say force is like this, and this force is like this. So net force is 0, and net torque as well is 0 because about z-axis, because forces, all the forces are either parallel to axis of rotation or perpendicular to axis of rotation and crossing from the z-axis. Line of force is passing through the z-axis, so net torque is 0. So A option is correct. And next thing, for when phi is pi by 2, if phi is pi by 2, and if we see from the upward, then diagram becomes like this. Wire is this infinite wire, current is I, and this wire is like this infinite wire, current is I, and loop this side we are watching from the up, and here current is we can say that coming towards us, and here a wire current in going inward, and here is current I is like this. So force on this, we can say this length is root over E square plus L square. This angle is let theta. Then force on this wire, which is perpendicular to the plane of paper, we can say that due to this force is like this is F due to magnetic field of this wire I, current I, and one force is like this, and net force can be written, and similarly we can write for the torque also. So here if we say about the net force, so which is in this direction, and if this angle is theta, this angle also be angle theta, which makes net force, and this force is perpendicular to this line, so this angle is basically 90 minus theta, and similarly we can write for this is the angle theta, and if this angle is theta, then this is 90 minus theta, and this angle is also theta. And this is again 90 minus theta, total is 90 minus theta. So net force towards left becomes twice of F sine theta, and here sine theta can be written as this distance is L divided by hypotenuse is root over A square plus L square. So this force and torque of this force we can write as torque is equals to 2F sine theta multiplied by length is L, perpendicular distance of force is L, and on the two sides torque is 0 because there is force net torque on that is 0 about z axis. So this is the torque due to 1, and due to 2 this is the torque. Two wires, two sides. So net torque can be written as 4. Value of force will be I is the current, and L is the length on which, 2L is the length on which we are observing the force, and ILB, B is the magnetic field, and magnetic field due to this infinite wire will be mu naught I divided by 2 pi, and R is the distance, which is root over A square plus L square. So this is the force, and sine theta is L divided by root over A square plus L square, and L is the length, and next thing multiplied by 2, and from here what it becomes, torque is mu naught four times of mu naught I square L square divided by pi A square plus L square, and which is given in option C, and distance A also comes out here. Sorry, we are talking about the torque, so it is at distance 1L must be here A. So next thing here, this is the A, and A, we have forgotten 1L also, we have written 1L, L cube we have to take, but 1L is A. So this is the net torque, which is given in option C. So option C is also correct. Thank you.